Welcome, and so today we're going to be starting by talking about functions and relations. Now the reason this is going to be important is that a function has one input and can then only have a single output. Whereas for a relation, it's possible that it takes something and it could have multiple outputs that are all valid. And this becomes a problem because generally speaking, it then becomes confusing as to know what was the actual output. We've actually dealt with the relation already. You probably just never thought about it before. If I take something very simple like this, x squared is equal to 9, okay? And so immediately, lots of you would go, yeah, well, we know what the solution to this must be. We take the square root of both sides and we'd get x is equal to 3. But I would argue that there is an equally valid solution, which would be x is equal to -3. So we can actually end up in a situation in which a relationship can have multiple solutions. And in a way, a function having the multiple outputs as well. So in this case, you would know that we can take the square root of 9, but we have to put plus or minus in front of it, because we could either take the positive or we could take the negative. And so in this way, the plus or minus is a type of relation, because it's giving us an option. Well, either it's 3 or it's -3, and we can't be certain which is the true output because they're both valid outputs. So we have already seen relations before. The goal of today is to look at how can we actually recognize them really easily. And we do it using something called the vertical line test. Okay, so the vertical line test is as simple as it sounds. You draw a vertical line on a graph to see whether or not it is a function or relation. So let's have a look at a few. So let's imagine we have a function that looks like this. Let's say x is equal to y squared minus 3y. And we go, okay, well, what does this look like? Well, let's jump into Desmos and have a look. So as you can see here in Desmos, I have got this great version of it up. You can see that it's all quite clear to have a look at. And the thing is that we can tell this is a relation straight away by drawing a vertical line. So let me just annotate on top of this. Alrighty, so this is the graph. It's of x equals y squared minus 3y. And we can prove that it is a relation because it fails the vertical line test. We draw ourselves a vertical line and we can see that it crosses at 2 places. Okay? Therefore, it is the wrong sort of relationship. In this case, we would call this a one-to-many relationship. Why? Because for one input, there are 2 or many outputs that are possible. So for the same x coordinate, we're getting multiple solutions. And so this would be an example of a one-to-many function. What about a more straightforward one? Let's do something like y is equal to 4x. Okay, well, I can sketch that. I don't need Desmos for this. Okay, so y equals 4x is going to look something along the lines of... Ooh, turn off my snap grid. It's going to look something like that, right? And the question is what's this relationship? Well, for one input... Oh, I've moved it a little bit too much. So for one input, x, how many outputs does it have? Well, you can see there's only one output. It's this one here. And you can see that that's the only one that it appears to be. So, therefore, this relationship would be 1 to 1. And so this would be considered a function. Alrighty, so we have 1 to 1 as a function. We said 1 to many is a relation because it fails the vertical test. Whereas this graph here is a 1 to 1, which makes it a function. Let's look at another one and see what we think. So let's have a look at something like y is equal to x squared. We're going to be dealing with quadratics a lot this chapter, so it's good that we get ourselves a bit of practice. So the graph of this looks like something along the lines of, oh, bit wonky, but you can see here, right, it passes the vertical line test, right? Like no matter where you draw the vertical line, it's only ever going to cross one point at a time. However, the difference is that many inputs get us to the same output. For example, here and here, right? Let's do something called the horizontal line test, where we can see here that there's multiple inputs here that are giving us the same output. We call this relationship many to one, okay? Meaning that there are multiple inputs that give us the exact same output. Doesn't matter whether we put in 2 or -2, we get the same output of 4. Okay, so that's a many to one relationship. And I'll show you just one more for fun, which is the circle relation. Now I'm telling you already it's a relation, but it's an interesting one. So if you put this into your calculator, which is a bit difficult, probably easy would be to just put it into Desmos. If you type this into Desmos, you'll see that the picture that you get on the far side is a perfect circle with a radius of 1. Now this actually fails both tests. So it fails the vertical line test and it fails the horizontal line test, meaning that for one input, there are many outputs, and for many outputs, for the one output, there are many inputs, meaning this relationship is called many to many. And this is indeed a relation. So the way we can tell whether something is a function or a relation is entirely based upon the second part of it, whether it's many to one or many to many. Remember, this many to one here is in fact a function, because for every input, there's only one output. Doesn't matter if multiple inputs give us the same output. So we have a 1-to-1, which is a function, many to one, which is a function, one to many, which is a relation, and at the very bottom, many to many, which is also a relation. Alrighty. See you in the next one. Goodbye.